Hello, M417 Trig Pre-Calc students. I am here. I'm with my son, so you might hear some baby noises, but I am here to talk to you guys just quickly. I know you have your own videos from Mr. Hochstetter and Mrs. Batista, but I am here to talk a little bit about continuity and just some generalizations that you might want to make from watching these videos. The way I think of it is this. Guys, when we have functions that look like numbers 1, 2, and 3, this is actually from worksheet 3, which is homework for you. When you guys have functions that look like this, so this first one is linear because it's just an x. The second one is an absolute value, which looks like a v. And the third one is a square root, which kind of looks like a hill. Like I said, the first one's linear. So when we have these like normal functions that we've worked with, you know, in Algebra 1 and Algebra 2 and so on, those are going to be continuous, okay? It's when we have rational functions. Rational functions look like fractions, okay? So I'm putting a box around all of the functions that look like fractions here. 4, 5, and 6. These are all rational functions. Those have discontinuities, and the ones with the fractions, the rational functions, typically will either have an infinite discontinuity or a point discontinuity, also known as a hole. All right? When the function is what we call piecewise, which looks like this, okay? How do I know when it's piecewise? It's piecewise when it has this like weird brace, and then there's two equations with it, okay? That will either have a jump discontinuity or it will be continuous. Those are your only two options. Notice number 8 is a fraction, so it's either going to be infinite discontinuity or a hole, which is a point discontinuity. Again, piecewise functions will only be jump or continuous. Regular functions like 1, 2, and 3 will always just be continuous. Those are generalizations that I would make when it comes to these types of problems. So numbers 1, 2, and 3 are all continuous just because of the shape of their graph, okay, which I drew kind of right above each function. Oops. Okay, sorry. My baby is making noises. I'm just trying to help him. All right, now, number 4, I said it's going to be either an infinite discontinuity or it's going to be a point discontinuity. A point discontinuity or a hole occurs if something cancels out. All right, for number 4, nothing's going to cancel. You okay, buddy? Nothing's going to cancel because nothing can cancel. For example, number 5, these x minus 1s can cancel, so that's going to be a hole. But in number 4, nothing cancels. So that means that there's going to be an infinite discontinuity. And, of course, we want to know where is that going to occur. So it's going to occur where the vertical asymptote occurs. This is all Algebra 2 kind of coming back at you. Calculus has a lot of Algebra 2 in it, okay? So my vertical asymptote occurs where the denominator equals 0. So x minus 3 equals 0, set it equal to 0, solve for x, so I'm just going to add 3 to the other side, and this is where the vertical asymptote is, which is also known as an infinite discontinuity. So it's an infinite discontinuity at x equals 3. Okay. That was number 4. Number 5 I already kind of started to talk about, and that is going to have a point discontinuity. So notice that something canceled, so there's a hole. There is nothing left over in the bottom. So this is called a point discontinuity. If there is something left over at the bottom, it actually is going to have more than one discontinuity. You okay? Okay. And the point discontinuity is going to happen at x equals positive 1. Now, how did I get that? I just took the bottom again, or actually I took the canceled factor and set it equal to 0 and solved. So x equals 1. So it's a point discontinuity at x equals 1. All right, number 6 is super quick because we already did one like this. This is going to be an infinite discontinuity because nothing cancels. And it's going to happen at x equals -1. Again, set the bottom equal to 0 and solve. Okay, number 7 is, again, the only options are, because it's piecewise, are that it's either a jump discontinuity or it's continuous. So how do I check that? Here's how. We take the first function and you plug in whatever number is with the inequality. So I'm going to plug in 0 to this equation. So 0 squared is 0. Okay. Next, I'm going to do the same thing with the second equation. So the second equation is 2x, plug in 0, so 2 times 0 is 0. If these two numbers that we get after plugging in the inequality number, if they are the same, it's continuous. So this one's continuous. If they are two different numbers, then there is a jump discontinuity at this x value, okay? Last but not least, this is just a step up because we have to factor. Everybody loves to factor. So this top part factors to x plus 3, x minus 2. And notice that now there is a cancellation. So this is a point discontinuity because it's a whole. And that's going to occur at x equals -3. I just take the canceled factor and set it equal to 0 and solve. Okay, that's the gist, you guys. Let me just show you a side example. So let's just say something factored like this. Okay, so here obviously there's going to be a hole because something does cancel. So that's going to be a point discontinuity at x equals -1. But then take a look at how I am left over with this equation. Since there's something still in the bottom, okay, something left over in the bottom, that indicates a second discontinuity. And since it's in the bottom, it's an infinite discontinuity. So this is a situation where there might be two discontinuities, and that's going to happen at x equals +3. Again, set that bottom equal to 0 and solve. So there's a situation, I just kind of made that example up, where there's two discontinuities. To summarize, okay, these first three functions are just normal continuous functions that we've graphed before in Algebra 2. Those are all continuous. For rational functions, those look like fractions. We're either going to have an infinite discontinuity where there's a vertical asymptote, or a point discontinuity where there's a hole. And last but certainly not least, we will have a jump discontinuity when there's a piecewise function, only if after plugging in our inequality number we get two different values. Okay, so those are all of the discontinuity situations. Hopefully this helps kind of sort everything out for you.